Okay, so here we're going to do an example, and we're going to calculate the electric field at some distance z above the midpoint between two equal charges. And these charges are separated by a distance t. What we want to focus on here really is how to set up the solution to this problem. Now the first thing I'd like to do is I'm going to kind of just draw a very simple schematic of what we are doing. So this is going to be the x-axis, here's the z-axis. So we have a Q, which is going to be located at some distance from our origin, so it's going to be minus x. We have our other charge, which is going to be located at a positive x. And we're measuring the electric field at some point, a distance z above the origin or above the midpoint between those two charges. So the first thing we want to do is to write down what our field and source vectors are. So for our field vector, we have r will be equal to z hat. Okay, remember it's that distance from the origin and it's in the z hat direction. Now for our source vectors, we're going to have two of them. We're going to have one which is along the positive x and one which is going to be a minus x. So here for our source vectors, let's go for the negative x first. So we have r prime, which is equal to minus x hat. And for the positive, we have an r prime, which would be the positive, that's equal to plus x hat. Okay, so that's the first step. Next step, we should write down our separation vector. Okay, so we'll have two of these. So we're going to have r minus r prime to the negative, which is equal to z hat minus x hat, so we have a plus x hat. And for our negative, we have r minus r prime plus, which is equal to z hat minus x hat. And just to show you where these are on our schematic is this one here is our r minus r prime negative, and this other one here is r minus r prime positive. And we can now write out our unit vector for each of these. So we would have r minus r prime negative over the magnitude. And so this will be equal to z hat plus x hat over the square root of z squared plus x squared. And our other unit vector is r minus r prime positive of that magnitude between the two, which is going to be equal to z hat minus x hat over the square root of z squared plus x squared. Okay, so now we're all good to go. Just recall that the distance between our two charges here is d, so the distance of one charge from the origin is going to be d over 2. Okay, so we're good to go. Let's write up our equation for the electric field. So the electric field for r be equal to 1 over 4 pi epsilon naught times the charge, which is q, over the distance, the r minus r prime to be squared, and our unit vector at the end. Now what all we have to do now is to plug what we have over here into this equation. And remember, since we have two charges, we have to sum up the contribution due to both charges. So if I write this out, what we're going to get is 1 over 4 pi epsilon naught. And we've got the contribution from the charge located at positive x and the charge located at the negative x. So we have q all over the square root of z squared plus x squared to be squared, so all over z squared plus x squared times a unit vector, which was z hat plus x hat, divided by square root of z squared plus x squared. Okay, so that was just one of the charges. And then we have the contribution due to the other charge, so plus 1 over 4 pi epsilon naught by q over z squared plus x squared, and the unit vector, which for this one is z hat minus x hat over that magnitude. So it's z squared plus x squared. So hopefully what you can see here is we have now two components. We have our electric field in the x direction and also the electric field in the z direction. Now, just by looking at this, we can see that the x components are going to cancel. Okay, we've got a positive and we've got a negative. So the electric field, the x direction, is going to be equal to 0. And then we just have to sum the contribution in the z direction. So now what we have left here is our electric field be equal to 1 over 4 pi epsilon naught by 2q z all over z squared plus x squared power of 3 over 2, and it's in the z hat direction. So now just to complete this, what we do know as well is that x is equal to d over 2. So we have our electric field be equal to 1 over 2 pi epsilon naught by qz divided by z squared plus d over 2 to be squared all to the power of 3 over 2. It's in the z hat direction. Okay, and this last expression here is our final answer.